Hello there, and welcome to an introduction to Kubernetes services. In this introduction series, we will look at what are Kubernetes services, why we want to use them, when do we use them, and how do we use them, as well as the different types of Kubernetes services that we have within Kubernetes. Now, let's assume this is our Kubernetes application, and we want to deploy this application to our Kubernetes cluster. Now, this is our K3s Kubernetes cluster that's running on Civo. Now, how do we get this application into our cluster? Within the cluster, we will have several different nodes, depending on how many we specify upon spinning up the cluster, right? So we have those different nodes, and on those different nodes, we can spin up pods. Now, a pod will contain the running container of our application in most cases. So we can pack up this application into a Docker container or any other container, doesn't have to be Docker, and then we can deploy this container onto our Kubernetes cluster, and it's running as a pod, which is one of the smallest resources within Kubernetes inside of our Kubernetes cluster. Now this pod will, for example, live on node 1. Now we have two different other nodes, right? Node 2 and node 3. And in a lot of cases, this pod might die eventually. It might die at some point. And then Kubernetes will have to spin up a new pod to replace the dead pod here. Now, to make it even more resilient to breaking down, we want to have pods running on all of our nodes, at least multiple pods. So, now what we could do to spin up those pods, to spin up our application, our container image, and run it in our Kubernetes cluster, we can use pure Kubernetes manifests. We could use templating solutions such as Kustomize, and we can use Helm charts. Now, there are other tools such as developer platforms that you could use instead that will take several different opinionated decisions to deploy your application and make it running into a Kubernetes cluster. But since we want to learn Kubernetes and how to do it ourselves, we're going to use Kubernetes manifests, pure Kubernetes manifests for the sake of this video. Now, when we go ahead and we deploy our application, we want to make sure that it's accessible from the outside world. So we want to make sure that somebody, a user, can request access. Let's say this is our user. That the user is able to send a request to the running application within our cluster. And this is where Kubernetes services come in. So let's spin up our pod. So I have here my example application. Let's open it up. As you can see, I have here different folders. I have a manifest folder with a deployment and a service that we're going to look at in a second. And then I have a pod.yaml file. Now, I'm currently connected to my K3s Kubernetes cluster. So if I say kubectl get nodes, I will see that I have three K3s nodes running within my Kubernetes cluster. So within that cluster, I currently don't have anything running within my default namespace. So we're going to go ahead and create a namespace. Create namespace example. Once the namespace is created, we can now deploy this resource, this pod resource. Now this pod will just basically refer to my container image that holds a simple node application that's specified within this Git repository. And spin that up. Go ahead, kubectl apply -file and hack folder, and then pod.yaml, and we want to deploy it to the namespace example. So when I now go ahead and say I want to get everything within my namespace example, I can see that I have my one pod running here. And it's called node example pod, like specified here. Node example pod. The thing is, if I go now ahead and I delete this pod, right? Delete pod, note, example, pod in namespace, example. And I query again everything that's within my example namespace. The pod is gone, right? I've deleted it. I've created this one resource and I've deleted it. In Kubernetes, we can use something that's called reconciliation. Reconcile. So we reconcile our resources. Does this work? So let's assume we spin up our pod, right? We want, whenever this pod dies, we want to have a new pod being spin up within our Kubernetes cluster. So whenever this pod dies, we want to have a new pod spin up. Now in this case, when I deleted the pod, it did not happen because the pod in itself is a finite resource. It does not do this reconciliation. So what we do instead is we use deployments. And deployments allow us to specify how many pods we want to run within our cluster. And then once we provide Kubernetes with our deployment resource that specifies how many pods we want to run, as well as what kind of application we want to within our cluster, it will take care of the reconciliation. It will just automatically, when we delete any of the pods or any of the pods dies, it will spin up a new pod to replace the existing pod. Now we can go ahead and we can have a look at such a deployment resource. Now this is a deployment resource. As we can see here, we have our API version, the kind deployment. Then within the specification section, we specify our replica set. So we're saying we want to have a replica set of 2 pods running within our Kubernetes cluster. And this will make sure that at any point in time, there are 2 pods running. If one of the pod dies, a new one is spun up and the other pod is still existing there. So that means at any point in time, we should be able to access our application, at least one pod of our application. Now I've specified a selector, and the selector will become important in a little bit of time. And then we have here our template and specification within the template that specifies basically our container image. And we will get to the container port in a second and the other specifications within here. What's important right now is that there's a label called node application, run node application to be precise. It's a key a value to that label. So we want to deploy this specific deployment to our Kubernetes cluster, since right now there's nothing running. So we're going to go ahead and we specify kubectl apply file in manifest, and then deployment.yaml. In namespace example. We always want to have everything within a namespace so we can easily clean up our cluster afterwards. So kubectl apply file manifest deployment YAML in namespace example. So we've created that. Now we want to go ahead and check out what's going to be spin up within our example namespace. Now, as you can see, we have here our deployment resource that we just specified within the YAML. And then we have here our replica set. The replica set specifies the number of desired pods. Now, as you can see, we have 2 pods running right now within our cluster. And as you can see right now, they don't have a nice readable name like we had before. Instead, the nice readable name is within our deployment. So when I delete this pod now, kubectl delete and then pod in our namespace example, we can see that a different pod had been spun up. So while this pod is still the same, as you can see here, the other pod, this one died, and a new one had been spun up. So the thing is, right now we could port forward to one of these pods to access our application. So I could go ahead and say, okay, I want to access this pod right now. So I can say kubectl port forward to this pod in namespace example, and it's running on port 8080. Port 8080. So now I will be able to access my application through localhost 8080, saying hello world in my face. Awesome. Great. So the thing is now, right now, I'm accessing my application through localhost, through the specific pod. Now, what happens if the pod dies? If the pod dies, I won't automatically reconnect to another pod. So let's say one of the pod, this is the pod, and this is the other pod. And right now, so pod 1 and pod 2. Right now, I'm accessing through port forward this specific pod. Port forward. If this pod dies, the link here is going to be broken. And I won't be able to access this pod anymore. And this is where Kubernetes services come in. The service will basically, instead of port forwarding, what we will do, we will deploy a Kubernetes service. And this is all within our deployment. So this is our deployment. And the Kubernetes service will basically specify how we can connect to our deployments. And in that case, if one of these pods dies and a new pod is spun up, I will be automatically forwarded to the other pod. Now, if that pod dies, and then at this point the other one is hopefully spin up again, it will route me back to the other pod that's alive. Now, if both pods are alive, I will be just routed to any of the pods or the pod that has the least traffic. But that's additional configuration that we don't have in place right now. So a Kubernetes service basically allows us to connect dynamically to the different pods. Now let's assume we have our front end. And the front end has, let's say, 3 different pods. Then we have our backend. The backend might also run several different pods, as in this case. So all the same pods. And then we have our database. Now, these are all different pods with different endpoints. Once we spin up a new pod, it's assigned an endpoint, a pod endpoint. And that's like an IP address of, I don't know, something like that, 0.1, and then the next one will have 0.2 or something. So they all have different endpoints. Now, if the pod dies, a new pod with a new endpoint is spun up, and this endpoint will be different. So we cannot assign the backend to directly always talk to this endpoint because it will always change. That wouldn't work. It would break our flow, right? It would be tightly coupled between those different pods and the different endpoints, and we do not want that. So what we do instead, we spin up services between those different sections of our application, let's say. So we have here one service. And then we have here a service for our front end, we have a service for our database. Now in this case, the service will be assigned a specific endpoint or a label to it. So we can tell, basically, we can tell the backend, this is the service that it always has to communicate with the front end. And this is the service that the backend always has to communicate with the database. So we don't care anymore about the specific pods that are running, but instead we just care about the different services that are attached to the deployment. So in this case, this is one deployment. In this case, this is another deployment. In this case, this is, for example, another deployment. So usually you will have, for each deployment, you will have a specific service. And this service allows you to communicate with your deployment, with the different pods within your deployment, independent of the endpoints that are attached to your specific pods, or independent of which nodes they are running in, and so on. Now we have 3 different types of Kubernetes services. And then there's a 4th type that's hardly used, but we will take a look at it as well. The default type is cluster IP. Then we have node port, we have load balancer, and we have something called a headless service. And we're going to take a look at them in a second. So as you can see, we can spin up a service that dynamically routes the traffic to our deployments. So going back to our running application, if this pod would die now that I'm forwarding to this specific pod, we would lose access to it. So let's spin up our service and connect directly to the service and show you how I can delete the pods by still being connected to the service. Apply. Let's apply our service in our namespace example. So as you can see now, we have a new resource called service and a node application. Now in this case, I specified it to be node port. The default will be cluster IP. In this case, it doesn't matter. We will take a look at that in a second. Now as you can see, it's accessible through port 3000. So I can go ahead and I can say kubectl port forward, and then service, node application in namespace example. And I want to forward to port 3000. So I can just specify port 3000. And this should forward my service. Now in this case, my application is actually running at host 8080, but I'm accessing through localhost 3000 as specified within the service. Now we can go ahead. If I open port 8080 right now, it won't open it. However, if I open port 3000, it will go ahead and I will display again, hello world. Awesome. So now that this is running, I can open up a new terminal, and I'm still connected to the same cluster. And then I can go ahead and I say kubectl get all, and I can just delete this pod. So what we will see is that a new pod is going to be spun up, and we still have access at any point in time through the service to our application. So kubectl delete in namespace example. Now this is deleting right now. We can have another look at how it's deleting it. Or it already spun up a new one. As quickly as that is. So at any point in time, we were able to access our application through localhost 3000. It should be. Let's reconnect and see if we can access it now. And here's again our application. Now, obviously, using port forward is always a little bit clunky. So later on, we will see how we can use ingress or service mesh even to establish communication between our different services. So like we've seen here, as our application grows, it will get more complex, meaning we will have difficulty routing the traffic from the front end to the database, and to ensure that the connection between all the different pods is ensured. So an ingress can allow us to access our application securely from the outside world, because this is all still within our Kubernetes cluster. This is all packed up within our K3s cluster. And we want to be able to access from the outside. At the same time, a service mesh will then ensure that within our cluster, we will be able to access the different and route properly the traffic between those different endpoints. Now in the next video, we're going to take a look at cluster IP, node port, load balancer, and in the next video, headless services.